Hello, and welcome back to Quantitative Reasoning Online. Today we'll be doing lesson 17D preview. Do note I have a link update. In this video, they are going to have you watch a video, and the link they gave in the video doesn't work. So I went some searching, I found it. It is now an archive versus active EPA.gov. So there's a slight change in the address. Now it says archive, and they lost a hashtag. So let's 17D, which is can you feel the heat, with 3 questions. And let's go look at 17 Part D preview. In this video, or in this lesson, we will identify different variables associated with climate change from video, read data from a scatter plot, calculate a percentage increase, interpret the rate of change of a trend line, and identify the strength of a correlation. Sounds like a busy lesson. So let's see, in the next class you will begin to understand climate change and the power of data to communicate information and a message. You will use the following concepts and skills from previous lessons. Use a spreadsheet to find a regression line, find the R-squared value for that trend line, interpret the slope of the trend line, and categorize a correlation using R-squared or R. The tutorial for the preview of lesson 17, Part D, Can You Feel the Heat, begins here. So watch the greenhouse effect from the Environmental Protection Agency website at this, what I was saying is not correct. So this will not work to find it. So, okay. So why don't we take a second. Let's go back to the page here, and if you just cut and paste this guy, into the search bar, you get this guy, and all you gotta do is just watch the video. And again, I don't know if you can hear the video, so I'm not going to play it. So do that yourself. It's about a 3 or 4 minute video, maybe 5 minutes. So put me on pause and go and watch the video. Then come back and we'll discuss the questions then. Okay, so hopefully you've spent some time and copy the link and watch the video. So let's look at the questions. What is a greenhouse? Why is what is happening in the Earth's atmosphere called the greenhouse effect? So if you have to, watch the video again and answer these questions to yourself. What is a greenhouse? And what is happening in the Earth's atmosphere called the greenhouse effect? B. How is the greenhouse effect good for the Earth? Okay. And the video basically said why we need it. Hint, it'd be mighty cold without the greenhouse effect, even with the sun. And C, how is the greenhouse effect bad for the Earth? Okay. That was all stated in the video, so you need to, if you haven't watched the video, watch it and be able to answer these questions to yourself. Again, hint, too much of a good thing is all things in moderation. Too much of a good thing could be bad. Okay. Recall from lesson 8 and 9 that the process of finding an algebraic representation that best fits data is called regression. Remember, have data, best fit line, and how close it fits a line, an R. Because there are two statistics used to measure the strength of the fit regression, the correlation coefficient R and the coefficient of determination R squared. When R squared is close to 1, there's a strong correlation. It could be positive or negative correlation. Correlations to be positive when the variables increase together, or negative when when one variable decreases where the other variable increases. So in this case, X is increasing, Y is increasing. So when they both happen at the same time, and as one goes up, one goes down, either negative. So here's some data, more data. The following graph shows the annual average CO2 concentration as collected by the National NOAA at the Observatory Mauna Loa, Hawaii. So that's in a volcano. Assume the relationship is linear. The regression line or trend line equation and coefficient of determination for the data is shown on the graph. Okay, now R squared is that. R is positive because as years go up, CO2 is going up. Okay, so let's see what they want us to do. Part A, estimate the total growth in carbon CO2 from 59 to 13. So total growth, 59 to 213, and express the result as a percentage change. All right. So let's see, looks like we have, can't blow this up, from 2012, looks to be about, I'm going to call it 400. And in 58, let's call it 50, let's call it 310, all right? So percent of change, stupid light. So 400 minus 300 over, 310 over 310 is what? Calculator, so 400 minus 310 divided by 310 looks to be about 29, somewhere around 30% increase. So we've had 30% increase between 58 and 2012. %. Hint. Yeah. Now let's say about 25%. It's a 318, about 395. Well, again, that's all depends on how well you interpret the numbers. So they say 25, 30%. Part B. According to the trend line, what is the rate of annual change / increase in carbon dioxide concentration? What is the rate of annual change increase? That sounds like a slope equation. So per year, it looks like we went through a change of, I used their numbers. They said a growth of 77 parts per million from 59 to 2013. So 77. So 77 ppm over 2012 minus 1959 for how many years? That's a 12 minus 3, 10.5 is 5, 0. Well, 53 years. All right, 53, yeah, 53 years. So let's find the slope. 37 parts per million divided by 53 years, about 1.45 ppm per year. Slope trend line is 1.496. Oh. Close enough. So I could just use one off the equation. So, hang on a second. Yeah, 1.496 ppm, 1.55, pretty close. Is the correlation between time and CO2 concentration strong or weak? Well, R squared is 0.9866. That's pretty close to 1. So I guess that would be pretty strong. Very strong. All right, sure. All right, question 3. In May 2014, the White House released the National Climate, a lot of words. Read the highlights of the interactive report at HTTP this stuff. Highlights and data from this report will be discussed in the next lesson. After any report, do you think climate change is now an important issue? Let's go through the report. You plug in, this is what you get. And next we want the overview. Similar to an executive summary. Explore the overview. Intro. So you would need to spend some time and read this on your own. Play with it, investigate it. And make your own decision. So again, read the highlights of the interactive report, the highlights. So I'm going to come to this page. Overview. Overview. And once you get this page, just scroll down and start reading and investigating it. And make your opinion on whether you think climate change is now an important issue. All right, see the rating. How confident did you identify different variables associated with climate change from a video? Read data from a scatter plot. Do we do that? Oh yeah, that was the Mauna Loa data. Calculate percentage increase. If I have better graphs to read the data off of, any change of a trend line, basically the slope, and of course reading the R-squared factor. Alright. So from this one, you will need to do on your own the analysis of this here report. And of course answer some questions. This greenhouse video of being able to answer these questions for yourself based on this video. So with that, I say good evening, and I'll see you later with the questions. These guys.